Hey, good morning, everybody. This is Mr. Ainsworth, and we are in MRWC here, prepping you for part 2 of Activity 7A3. And this is the second of 2 prep videos to get you ready for this activity on piecewise functions. The activity is broken up into 2 parts. Number 1 is all about graphing the piecewise function, and part 2 is all about writing the function given the graph. So it's reverse process here. So what I'm going to do is I'm going to use Desmos here to help me out with learning from the piecewise graphs. I'm going to show you how to enter the functions in of a piecewise function given the certain domain restrictions. And then we're going to learn from the graph of how it behaves and what it looks like. And then from that, we're going to go to the next set, part 2, where I give you the graph and then you have to write the function of all the pieces, whether they're linear, have negative slope, positive slope, horizontal. It could be curved. I mean, there's a lot of different possibilities here. So we start we start by learning how functions behave and in interpreting this, because that's the first thing, and you have to get used to it. So first thing we need to do is set up Desmos, because you're going to you're going to save all your work in Desmos. So obviously all my students have an account in Desmos where you save all your work. So you go over here to Desmos here. When you open up Desmos in the graphing portion of their calculator here, these 4 functions are the default. They always come up here. So you X them out, you delete them. So you can start fresh. You come up here to the untitled graph and give it a name, like 7A3 Prep 2. All right, this is Prep number 2. So let me title that. So this is Prep number 2, the second one, for part 2. So we're going to go over here. We're going to type that in. Always give it an appropriate title. So 7A3. Here we go. I already did this, so it comes up. That won't come up for you, but this comes up for me because I've worked with Desmos before. So give it the appropriate title. Prep 2, graphing piecewise functions, save it. So as you work in Desmos here, you're just saving your work. It's easy to print off and submit to Canvas. Okay, so, entitle this right here, put your name down. I'm Mr. Ainsworth here at Great Oak High School in the year 2021 during this crazy pandemic time. And I work at Great Oak High School, so GOHS for short. All right, I only say that because a lot of people go to my YouTube channel and watch my videos, and you guys are from around the world. So this is where I live. I live in Temecula. Well, I live in Wildomar, actually, but I'm in California, and I work at Temecula, Great Oak High School in Temecula, California. So here we go. We want to, in part 1 here, in this first one here, we want to graph each piecewise function in Desmos and learn about their parts and what they look like. Okay, we did this by hand, in my previous lesson, but still you're getting used to these functions and how they behave. So I'm going to use Desmos as our tool to learn from, and then we're going to reverse the process. I'm going to give you a graph, and we're going to come up with the function, okay, the piecewise function. So this piecewise function here has 3 parts. Okay, the first part here, part number 1, part 2, and part 3. And y is the same thing as f of x. You guys should know that from prior classes right here. So when you see f of x, you think y. Okay, so y is equal to -3 if -4 is less than x, which is less than or -1. This is what's called the domain. It's a restricted domain, but basically you just think of it as the domain. So when y equals -3, it's only defined from -4 to -1. Y is equal to -1 on the interval from -1 to 2, and then y is equal to 2 from the interval from 2 to 4. All right, so there's going to be 3 pieces here that we have to graph. So what is y, the first part here, piece 1, what does y equal to -3 look like from -4 to -1? And if you don't know what this is, and if you don't know what a constant function looks like, well, then you type it in, okay? So that's exactly what we're going to do. So mimic me here, type in y equals -3. And when you're entering the restrictions here, this is the restricted domain, okay? Because if you type in y equals 3, it's an infinite horizontal line going infinitely right and infinitely left. All right, but this function here, y equals -3, which is this horizontal constant function. Let me zoom out here, so you can see how it's down 3 at -3. All right, it's restricted, and it starts at -4 and stops at -1. All right, so you got to put that in. So what you do is you use these curly brackets, which are right above the square brackets on your keyboard, right next to the letter P. So use the curly brackets, and you type in this restricted domain. You just literally type it in. So you go -4 for a -4, less than. See, on the keyboard are these less than and greater than symbols. All right, X, which is less than or equal to -1. You just type it in, and then you'll see the restricted function. So notice that we don't have a continuous line going infinitely left and right anymore. Okay, it starts at -4, and it stops at -1. It has a starting point and a stopping point because this is the restricted domain of the constant function. Okay, so that's what it looks like, and of course we can go ahead and come over here and graph the function. So I'm going to do that. So piece number 1 is y is equal to -3. It's constantly -3 from -4 to -1. All right, so there's the first piece. So you learn from Desmos. This is called a constant function. You know, I'm going to color code things. Let me put the first function in red. So from -4 to -1. That's your first piece. And it's called a constant function because y is constantly well, it's constantly -3, right? Just look at it. Okay, and constant functions are always horizontal. So whenever you see a horizontal line, it's a constant function. It's a constant linear function. Constant linear function. Okay, it's a line. All lines are linear. Okay, so whenever you see a horizontal line, which you're going to see here in a little bit when I get into the later part of the activity here, you know it's a constant function. Notice that there's no x involved. Okay, the second piece I'll put in blue. Okay, and y equals -1 from -1 to 2. All right, so again, this is the second piece. So y is equal to -1. And again, this is a constant, right? -1's constant. It doesn't determine, is not determined by x, like these other pieces in example 2. Okay, so what does this look like? So you go to Desmos and you type it in. So y equals -1. And this is why I use Desmos, because this is the fastest graphing tool on the planet. Now notice that it's unrestricted here in blue. Notice that the function pops up. So you have to put the restrictions in. So you use those curly brackets again, which are right above the square brackets, and you type in exactly what you see. -1 less than x less than 2. So -1 less than x, all right, less than 2. There's your restriction. And notice that we have another horizontal line right there. Okay, the question is, are they open and then closed? And I'll get to that here in a minute when, I got to talk about that right now, actually. I forgot to do that because it should be open at -4 and closed at -1 on this graph. So I'm going to have to modify my first piece here. I just noticed that. Now, let me talk about that right now. So if you go trace along the function here, just put your cursor on the red, the first piece, and if you go far left to the left endpoint, notice it's undefined at -4. So it should be open circle there. Notice that Desmos even shows you the open circle if you hover above it. On the right side, it's closed. The reason why is because in the domain, if -4 is less than x, that means x is strictly greater than 4. So it's got to be open here. So I got to change the graph. So it's open here and closed on the right. So right here, this is open, and on the right, it's closed. And you could tell by looking at the inequality here. So when you see strictly less than, it's going to always be open. So right here, I can see that it's open, and then right here, I can see it's closed at -1. So when you look at the inequalities, if you see an equal to portion of it, it's going to be closed. If you don't see the equal sign, it's going to be open. Okay, so I apologize for not mentioning that earlier. Okay, now in the second function, both are going to be open because where y is equal to -1 from -1 to 2, both open. That's an open interval. So right here, if you go on Desmos here, it shows you. Look at that. If you go far left on the left endpoint, it's undefined there. On the right endpoint, it's undefined. So they're both open. So when you graph this middle portion here, you're going to be graphing a line segment from -1 to 2, but both endpoints are open. So open here, and there's piece number 2 in blue. Okay. So again, this piece right here is the middle piece. And the first one, you don't have to highlight your notes. I'm just trying to do this to make sure it's color coordinated. Okay. Now the third piece, let's do it in green here. So the third piece, y is equal to 2. All right. So you type that in, y equals 2. But notice that it's a continuous line to the left and to the right. It's infinite. So you got to restrict it from 2 to 4, closed. It's a closed interval from 2 to 4. So when you do that, use the curly brackets again. So I'm teaching you how to type in piecewise functions in Desmos, and I'm also teaching you how to recognize what constant functions look like, okay? So you're supposed to learn from this. So 2 is less than or equal to x, all right, which is less than or equal to 4. There's your restricted domain. And notice that we have another segment. It starts at 2 and goes to 4. And that's in green. So that one here, and they're both closed. So look at this. You on Desmos, you trace along the function. You go left side, it's closed. Right side, closed. It's defined on both sides because it's a closed interval. So right here and here, closed interval. And because it's a closed interval, you have closed points. So from 2 to 4. There's piece number 3. So in green. So if you just want to color code just to see if make sure you guys are following me here. So third piece is there. And again, you don't have to color code your notes like that. Just draw the graph, okay? If you like the coloring, okay, do it. Okay, save your Desmos graphs because you're gonna print this off and include it as a PDF. You're gonna do paperless. You're gonna print it to a PDF and just submit your PDF to Canvas. Just making sure that you guys are being honest and you're doing the work in Desmos and you're learning. Okay, that's part of the deal. Okay, you got to learn how to use the technology to back up what you do on paper. So when you see constants like -3, -1, and 2, they're horizontal line segments. These are horizontal line segments. Horizontal line segments. Okay, I'm talking about the constant functions. Okay. Now, if there was a variable involved, like in the second example, they're not horizontal, okay? Only if it's constant. Okay, let's just make that clear. Okay, so we're done with these functions, so turn them off. Just don't delete them. Do not delete these, okay? Just turn them off. You can turn a function on and off so you can only see what you want to see. Now, let's learn from this next one here. So we got y is equal to this -x plus 1. That's the first function. Y equals -x plus 1. And it's on a restricted domain from -4 to -2. So let's learn from Desmos here. So we can take y equals -x plus 1. Just type it in. And notice it's unrestricted. You know, linear functions are infinite in both directions. So you have to put this restriction in. So from -4 to -2. So you use your curly brackets again. And then you type in -4. Here we go. -4 is less than or equal to x, which is less than or equal to -2. Okay, simple. So now notice it starts at -4, 5, and then stops at -2, 3. And if you trace along the function, it's defined on both endpoints. Okay, which means that it's closed on both sides because they're less than or equal to. So keep that in mind. So let's go ahead and plot that. I'm going to do the first one in red. Just keep it color matching here. So we got first one -4, 5. The next point is left 2 up 3. So left 2 up 3. Here we go. Okay, there's your first piece. Okay, first piece, second piece, third piece. This is first piece. First piece. Second piece, third piece. Okay, next one. Now the next function, let's switch colors. So the next function is y equals 1 right here. That's a constant. Okay, because it's a constant, it's horizontal. So why? Because we learn from the past, right? We learn from the first example. Okay, so this is going to be a horizontal line from -2 to 1, okay, at the height of 1. So if you don't know what that looks like, still, you type it in. All right, so then you got to put in your restriction. So you go curly brackets, and you type in -2 to 1, open and then closed. So -2 to 1, open, so it's less than x, and then close, less than or equal to 1. So notice on this one here that it's not defined on the left, so it's open on the left, closed on the right. Open on the left, closed on the right. So let's graph that guy. All right, so open on the left, closed on the right. So that's piece number 2. And then now piece number 3, you just type it in again. So y equals 2x. All right, and plus 1. Now it's infinite because we haven't restricted it yet. It's restricted from 1 to 4. So enter the curly brackets again, and you start typing it in. So from 1 to 4. So 1 less than x less than or equal to 4. Okay? And notice that we have this third function here starts at 1 comma 3 and then ends at 4 comma 9. So here we go. So let's do the third piece. So this first one here, the first endpoint or the left endpoint, it begins at 1 comma 3, open. So 1 comma 3, open. And then over here at the endpoint, 4 comma 9. So right 4, up 9. All right, and then you sketch the curve, or sketch the line, and that's the third piece. Now that's how you use technology. That's how you figure things out using Desmos technology. But how would you go from the graph to the function? Okay, it's pretty straightforward when it's constant. All right, when y equals 1, when you see a horizontal line here, it's at height 1. All right, so you know y equals 1 at that point and then you just look at the x-axis here, and it starts from -2 and it goes to 1. All right, but how do you go backwards? I mean, like on this third piece right here, how do you do that? Well, that's the key. Okay, and so what you want to do is go back to Algebra 1 basics. Okay, so let's start off with the first piece. So the first thing I know is that these are linear functions because they're lines. Okay, that's the first thing I recognize. And so if I didn't know what the function was, and if I was just looking at the graph, I'd say, okay, piece number 1 is a line. It's a line segment, so it's linear. Okay, that's the first thing. It's linear. And all linear functions look like, or can be written as y equals mx plus b. Okay? So what you want to do is you want to use your Algebra 1 skills. All right, so when you go from point to point, let's say let's give these some names, like A to B. If you're going from A to B, you go down 2, all right, and you go right 2. And because of that, I know the slope is -2, down, rise over run, -2 divided by 2, which is -1. And notice that the slope up there is -1. I also know if I continue that, if I go down to right 2, I end up at the y-intercept right here. I intersect the y-axis at 1. So I know that b is equal to 1. And so if I know that, then I just write the function y is equal to -1x plus 1, which happens to be right there in the function. So when you look at a graph, you analyze its slope and its y-intercept to write the linear function. So for linear functions, it's pretty straightforward. It's just Algebra 1 basics. Okay, so one more time. On piece number 3, how do we get this 2x plus 1? How do we get that? So you look at slope. Okay, so let's call this C and D. Now, how do you get from C to D? Well, you can go right, all right, and you can go up. So if you go right 3, 1, 2, 3. You count up 1, 2, 3, 4, 5, 6. And so the slope is always rise over run, so 6 divided by 3 is 2. So I know the slope is 2, and there is your slope, mx plus b. Now, how do you get the y-intercept? Okay, so watch this. We're going to using the slope of 2, which is the same thing as 2 over 1. You can go up 1, right 2. Okay, or you can reverse it. You can go down 2, right, left 1. So down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. And notice that I end up at 1. There's a y-intercept again. So for this function, I know the y-intercept is 1. And because of that, I know it's y equals 2x plus 1, which is up there in the function. So when you go from graph to function, you use Algebra 1 basics here of slope and y-intercept if they're linear, or if they're horizontal or constant, then it's simple. Okay, the question is how do you do it if it's a curve? We'll get to that in a minute. Okay, so what I'm doing here right now in the first two examples is like showing you how to use technology and understanding what the different parts are looking like. So if you see just a number, which is called a constant, these are called constants. Hopefully you guys know that already. If you don't see a variable, it's called a constant. Okay, -3, y equals -3. It's a horizontal line segment. Okay, so anytime you see that, or if you go backwards, if you see a horizontal line segment, then you know it's a constant. And so we're going to be able to go back and forth here. If it has some slope, well, then you got to figure out the slope and y-intercept. All right. Now this is a little bit more complicated on this one here. So on this one here, if you want to use some technology, let's turn these guys off. And let's go down here and enter the first function. So your first function is y equals -1/3 x plus 2. And again, this is linear. All right, so this first one is linear. So let's type it in. So y equals -1 divided by 3. And then you have to get out of the denominator right there. So click to the right, use the right arrow key before you enter x. If you don't do that, this is what happens. You put an x in the denominator and you get a rational function. All right, you don't want that. Okay, that'd be a mistake. So you go to the right and you type in x there and then plus 2. And now you have something that looks like it's a linear function. Okay, just look at the line right here, it's linear. You got to put the restriction in though. So again, that's where the curly brackets come in, right? As I keep on saying. And you got to restrict it from -6 to -3. So curly brackets, and then -6, less than or equal to x, and then strictly less than 3. So type it in, and now it's restricted. Now, if you're doing this by hand, the way you do that is you set up a table of values. And I'm going to show how to do that right now because I'm going to review how to do it manually. And I'll show you the 2-point method for linear functions. So if it's linear, all you need to do is use the left and right endpoints. Okay, so, and I'm talking about these guys, left endpoint, right endpoint. Basically, it's a start and stop. So you enter the numbers in. From the left endpoint is -6 and the right one's -3. You substitute them in the function and you get a value back. And I'll show you how it's the same on Desmos. So I got to take -6 and substitute in the function. So -1/3 times -6 add 2. Well, negative times a negative is a positive. 1/3 of 6 is 2, and 2 plus 2 is 4. So you get 4 here. And notice on the left endpoint, it says -6, 4 on Desmos. Okay? You do the same thing over here. You take -1/3 times -3 this time and add 2. Well, this -1/3 times -3 is just 1. Negative times a negative is a positive, and 1/3 of 3 is 1, and 1 plus 2 is 3. So we should get -3, and if you go over here to Desmos, it's at, oh, let me see. What did I write? Oh, I didn't type it in correctly. That's why it didn't jive. I put in +3 on Desmos, and it's supposed to be -3. So I was wondering why my numbers didn't match. Now this makes more sense. Okay, so on the left side, -4, 6, that jives. On the right side, notice that it's undefined or open at -3, because up here the domain should be strictly less than -3. But look where it's located, left 3, up 3. That's -3, 3, guys, and that's what I have in the table. So this one's going to be open, this one's going to be closed. So when you go to the graph, let's plot that. -6, 4, so go left 6, 4, And then, oh boy, hopefully I haven't put the right graph in here. And then negative 3 comma 3 open. So left 3, up 3, open, and then there's piece number 1. Piece 1 here. Okay. Now, so I just did it manually using the left and right endpoints of the interval. That's how usually I do it. And then of course you can use Desmos as well. Now the second piece number 2, is y equals this square root function. So y is equal to the square root of 9 minus x squared. What in the world is that? Okay, now what is this function? What does this look like? Okay, and the first thing I'm going to do is enter in Desmos, and then I'll tell you why it is the way it is. Okay, so we enter in y equals the square root of 9 minus the x squared. Just type it in, and look at this, we get a semicircle. The green one is the semicircle. Why is it a semicircle? Why is it a half of a circle? And there's a reason for that. So I'm going to come back over here, and I'm going to do some basic algebra here. I'm going to square both sides. So I'm going to square the left side, and I'm going to square the right side. And when you square the root x, or the root of 9 minus x squared, you just get 9 minus x squared. Okay, so all I did right there is I squared both sides. So y squared is y squared, obviously, and when you square a root, they cancel, giving you 9 minus x squared. And after that, I'm just going to bring the variables to one side to make it look familiar. So I'm going to add x squared to both sides, and I get x squared plus y squared is equal to 9. Now, I'm going to enter this in just to show you. Watch what happens. So I'm going to turn off the previous one, and I'm going to type in x squared plus y squared. X squared plus y squared, watch what happens, equals 9. And notice that we get not a semicircle, we get a whole circle with a radius of 3. From 0 to 3 is a radius of 3. Okay? So why is the given function half a circle, and why is this function the whole entire circle? Why is that? Well, I'll tell you why. Because if we were to solve it, okay, if we were able to go backwards, and I'm going to do this just so you can see it. Here, if I start off with x squared plus y squared equals 9, if I gave you that, and I said isolate y, I'd have to subtract x squared. So I'm basically reversing the process right now. And I get y squared equals 9 minus x squared. And if my goal was to isolate y, I'd have to square root both sides. And then I would get y is equal to plus or minus the square root of 9 minus x squared. In your last course, your instructor should have told you that when you're solving for x here in an equation and you root both sides, you have to have the plus or minus cases, the positive and the negative. So watch what happens here. When I enter in the positive and the negative, the positive is already in, it's right here. This is the positive root, y equals positive. If I enter in another equation, y equals a negative of the square root, the negative case of 9 minus x squared. Watch what happens. Notice I get the bottom half. So the negative of the root gives you the bottom half of the circle. The positive of the root will give you the upper half. So plus gives you the upper half, minus gives you the lower half. And if in the piecewise function here, it's positive of the square root of 9. I'm going to put a plus sign in here so you can see it. It's positive. I don't see a negative sign there, so it's assumed to be positive. So this is the upper half of the circle. Upper half of the circle. So when you see equations of this type, these are semicircles, guys. Okay, so let me deselect this, and this is what we're dealing with here. So we're dealing with a circle, a semicircle, that starts at negative 3, 0, goes up to 0, 3, down to 3, 0. So let's graph that. So let's plot. And these are both closed. The interval's closed. So these are all closed. Okay, it's a semicircle. okay, with radius 3. All right, and the last part. Okay, well, you should know the last part. Let me switch to green. Okay, this part right here, y equals 3. This is piece number 3. That's constant function. So since you know that already, because we talked about that earlier, this is a constant function to the right of 3, open at 3. So it's going to be open here because it's greater than 3. Okay, so y equals 3, you go 3 units up. So it starts at 3. So it's going to be open here. And so this is y equals 3, the third piece right here. And if you want to verify that, type it in. Y equals 3. And you put your restriction in. Okay, curly brackets again. All right. And you type in x greater than 3. So x greater than 3. Boom. And there it is. So notice that it continues there. It's open right there. See how it's undefined? It's open on the left and it continues to the right forever. All right, so when you see constant functions, sometimes they're line segments. They have a start and stop, but if the domain is infinite, like this is from 3 to infinity right here on the third piece, then it's going to be a continuous line segment to the right. Okay, but it's definitely going to be horizontal because it's a constant function. It's a horizontal function. So hopefully you're learning from this in the activity right now. You're learning how to use the technology to understand what's going on. You know, why is it a line? Why does it have slope? Why is this a semicircle? Okay, and so on. And again, you know, mathematics and technology usually tells you what you need to know. Now let's reverse the process. I give you the graph, we have to write the function. Okay, so this is what the main part 2 is about. Here we go. So hopefully you learned from the previous graphs. Okay, part 2, here we go. So write the function. We have 3 pieces. Okay, piece 1, piece 2, piece 3. So here f of x is going to be equal to, and then we've got piece 1 here, if something. We got a domain right there. This is going to be the domain, the restricted domain. And then piece 2 is going to be here on a specific domain. And then piece 3 is going to be here on a specific domain. So we got 3 pieces to write for obvious reasons, okay? Okay, so what I'm going to do is we're going to use Desmos to help us out and check our work, okay? So what I notice on piece 1 is that it's linear. Okay, so I'm going to analyze things. I know it's a linear. So this is definitely linear. And what you're going to do is you're going to write the piecewise function in terms of a linear function. Okay, y equals m or mx plus b. Okay, so here we go. You need to find the slope. So you go from point to point. Okay, and you know what? On this example here, it's not shown the... I couldn't get the graph to show open and close. So let's do this. Let's say that this left endpoint is closed. And this one's open. This one's closed. And this one's open at 2. Okay, there's a height of 2. This one is closed right here at -1. And this one's closed here as well. Let's just make that decision because I couldn't design, or the graph couldn't show it to you when I was doing this. So let's just make that assumption. So here we go. So this function here is defined from -4 to -2. And the way you know that is you simply go down, okay, and that's -4. And you go down, and it says -2. So I already know that the domain, this is the restricted domain right here, from here to here, is from -4 to -2. But we're not writing this in intervals, we're using inequalities here. So it's closed on the left, open on the right. So you say -4, excuse me, less than or equal to x, which is strictly less than -2. Oops, I missed the less than symbol. Strictly less than -2 because it's open on the right, closed on the left. Okay? So we're not using interval notation right here, we're using inequalities. That's why in all my lessons, you guys, I was going back and forth between inequalities and interval notation, just to help you guys see things better. Now I got to write the function. So I need some slope, I need the y-intercept. So let's talk slope. So I can see from A to B, I go down 1 and right 2. So negative 1 and then 2. So down 1, right 2. That tells me that my slope is negative 1 over 2, negative 1/2. And if I continue doing that, down 1, right 2, I end up at a y-intercept right here. So this function right here has a y-intercept of 2. So when you write this function, it should look like negative 1/2 x plus 2. So let's enter that in Desmos and see if we're right. So type in y equals negative 1 divided by 2. Get out of the denominator. Hit x, okay, negative 1/2 x, and then add 2. And then let's put the restriction in from negative 4 to negative 2. So curly brackets, negative 4. It's going to be less than or equal to x. So less than or equal to x, less than negative 2. Okay, and there we go. So there's the first piece of the function. So let's see if we're right. Left endpoint is negative 4, 4. Left 4, up 4, that looks correct. Right endpoint, undefined, open, but it looks like left 2, up 3. Left 2, up 3, that's correct. So again, Desmos says open on the right, closed on the left, okay, and it agrees with what I have on the graph. So far we're looking good. Okay, piece number 2, the horizontal function. Now this is horizontal. And because it's horizontal right here, I know it's constant. So horizontal means that we have a constant function. It's obviously at height 2, so y, this is y is equal to 2. It's a constant. All right, and again, it goes from negative 2 to, well, look at that, 0. Okay, now it's closed on the left, open on the right. So negative 2 less than or equal to x less than 0. So again, this is the domain. All right, go left to right on the domain. Piece number 3. It has some slope. I know the y-intercept right here. So b is negative 1. I know that. I need a slope. So to get a slope, I just go right and up. So right 1, up 2. Slope is 2 over 1 or 2. So my function looks like 2x minus 1. So this is 2x minus 1 from 0 to 2. So it's closed on both sides. So from 0 to 2. So let's type that in. Let's see if we're right. Oh, I got to type in the piece number 2. So piece 2 is y equals 2. Let's check that one. Okay, y equals 2. Curly brackets to set the restrictions from negative 2 to 0. So negative 2 less than or equal to x less than 0. Okay, so if you look at Desmos, negative 2, 2, left 2, up 2, that's correct. So Desmos goes closed on the left, open on the right. Okay, so piece 2 is correct. Let's check piece 3. So we're going to put this in here and we type it in. So y equals, again, your function is 2x minus 1, so 2x minus 1. Put the restrictions in and use the curly brackets and go from 0 to 2. All right, 0 less than or equal to x, less than or equal to 2. And then if you look at Desmos here, the y-intercept's at negative 1, which it is here on the graph. And then the right endpoint up here is right 2, up 3, so it better be at 2, 3, which it is. So you can use Desmos to check your graphs. So after you write the function, type it in Desmos like I did, and it better be the same. If not, then you're wrong. Okay? And that's what's cool. You can check all your work. You can check your activity. You can, on quizzes or tests, you can check your work as long as you have enough time. All right. Let's try this one. So again, we're going to use similar skills. Okay, we have 3 pieces. So obviously piece 1, piece 2, a semicircle, all hint, hint. All right, piece 3, horizontal. So this is linear. This one has slope. This one's horizontal, so it's a constant function. Okay, and then piece number 2, this is a semicircle, and hopefully you learned from my previous example what that is. Okay, and this one has a different radius though. This has a radius of 2, so it's a little bit different. Okay, Let's get started. Okay, so here we go. So on this one here, piece number 1, so we need to write the function f of x is equal to first function if on some restricted domain, second function on a certain domain, and third function on a certain domain. Okay, one piece at a time. So let's do the restrictions on the first piece. So I know that, notice that it hits the end of the window frame here. The third piece does not hit the end of the window frame, so it has a start and a stop. This one here hits the end of the window frame. Okay. Hits end window frame, which means it goes on forever in that direction. Okay, continues to negative infinity. So this one continues to the upper left, but the piece number 3 does not, because it doesn't hit the end of the window frame. So just as a little reminder here, if you want to, you can put a little arrow right here because it hit the end of the window frame. So it's going to take off to the upper left forever. Okay, so that's going to affect your domain. So when you look at the domain, and let's do open and closed again. So let's say that this one's closed, this one's open, this one's closed, and this one's open, and this one's closed. So go ahead and fix your notes because I couldn't do that on the computer program. Okay, so knowing that, this domain right here is going to go from, we look down here, this is at -2. So from -2 to the far left, to negative infinity, or from x values here have to be less than -2, or less than or equal to -2. So x is less than or equal to -2 because it's closed there. This is closed as opposed to open. I made a decision earlier. And again, if you're wondering why it's closed, well, I just made that decision. I had to just modify it because I couldn't do that on the graphing program. Okay, now what is the function? So we got to use slope. So the slope, pick a point. So you go down 1 and then right 2. So down 1 is a -1, right 2. So on this one here, m is -1/2, or slope's -1/2. And if you go down 1, right 2, you end up at this y-intercept. Down 1, right 2. You're right here. So I know it has a y-intercept of 1. So my first piece of the function is -1/2 x plus 1. So let's check that. So here we go. So deselect those, and let's put in this function here. And let's type it in. So y equals -1/2, all right, x, and then plus 1. And then you got to put in your restrictions here. So curly brackets, and you just type in x less than or equal to, looks like -2. And notice, there you go. It continues forever in that direction, see? Okay, so notice the start point right there, okay, is at -2, 2, and that's the same as on the graph. Starts left 2, up 2. So far so good. Okay, now we got the semicircle. Now, so let me go back to the previous one here. So on this one here, this circle, I forgot to mention one thing here, had a radius right here of 3. R is equal to 3. That's called the radius. Now notice there's a 9 involved. Now the general equation of any circle with center at the origin, let's put it up here. So circles, okay, with center at the origin, looks like this: x squared plus y squared is equal to r squared, okay, where r is a radius. And so if you compare, our equation was if we compare these two, x squared plus y squared is equal to 9. So in this case right here, r squared equals 9. If you compare the two right here, and if r squared is equal to 9, that tells me that r is 3, which it is. Okay, so if you know radius is 3, that means r squared is 9. So you just square the r value to get to the equation. You kind of need to know that because right here, in this semicircle right here, I know that the radius, which is this distance right here, r is equal to 2. So for the semicircle, I know it's r squared plus y squared is equal to r squared, okay? But r is 2. So we have r squared plus y squared is equal to 2 squared or 4. And then if you solve for y here, you subtract x squared. And you get y squared is equal to 4 minus x squared. And then if you square root both sides, like I did earlier, you get y is equal to plus or minus the square root of 4 minus x squared. And if you recall what I did earlier, I said the plus in the case is the upper half and the minus is the lower half. So we're going to take the upper half, okay? So which is the positive of the root of 4 minus x squared on a certain interval. Now this circle only exists from -2 to +2. So here we go. Open on the left, so less than x, closed on the right, so less than or equal to 2. Okay, so this is for circles with the center at the origin. If the center is not at the origin, that's a more complicated case, and I'll show that to you later. Okay, now the last piece, this third piece up here, this constant function. So y is always equal to 3. It's at height 3 right here. There's a 3, it's height 3, so y is always equal to 3 because it's constant, right? And it starts at 2 and goes to, it looks like 5. Okay, open on the left, close on the right. So from 2, not less than or equal to, strictly less than, but less than or equal to 5 because it's closed on the right, open on the left. So less than, and then less than or equal to. So it's open on the left, closed on the right. So if you want to enter in the last piece to see the function, let's do it. Okay, actually we have to enter in the previous piece too. So y is equal to the square root of 4 minus x squared. And then get out of the root, okay, and put your curly brackets in, your restriction, from -2 to 2. So -2 to 2. And notice that you have a semicircle right there, just like we do in the original graph. And then the last piece, the constant function, y equals 3. So that's a simple one. Y equals 3. Put in your brackets, your restrictions, from, let's say, 2 to 5. So 2 less than x, less than or equal to 5. And you'll see the last piece come in. Open on the left, closed on the right. Okay? So what's cool about Desmos is that once you write your function, which I did, and I did it without Desmos in the beginning, you check it with Desmos afterwards. All right? So make a note to yourself here to check with Desmos. Always. Okay, make sure you're right. Okay, the quality of your work is the most important. Okay, well, it's one thing doing your homework, it's another thing doing it right. And that's what a lot of people don't get, is that they just do it without any quality or concern for quality. And so what you guys have to do is be concerned with the quality. Okay, last example. This is the last piece. So we have 3 pieces in this example. Example 6. So 1, 2, 3. So we have f of x here is equal to, okay, first piece on some domain, second piece on a different domain, third piece on its own domain. Okay, so first piece is linear. And because it's linear, this is linear here, it looks like y equals mx plus b again. Okay, all linear functions behave like that. So we need a slope and a y-intercept. So the slope's pretty straightforward. Let me put the open and closed in. So let's say it's closed here, open here, closed here, open here, closed here, and it hits the end of the window frame, so it continues here. Okay, so put that into your notes first. So let's work on piece number 1. So we need a slope. So rise over run. So we're going to go down to right 3. Okay, so already my slope's -2/3, but I need a y-intercept. So I go down to right 3, down to right 3. And if you continue this line down, you'll notice, oops, that was bad. right there, you'll notice that it doesn't hit the y-axis at an integer value. Okay, so as I was saying here, sorry about the little interruption there. So we know what the slope is, but we don't know what the y-intercept is. I mean, if you look right here, the line crosses the y-axis between 0 and 1. So I don't know what it is. It's a fraction. And you don't guess, okay? You do not guess on the y-intercept because you probably get it wrong. I have no idea what fraction that is. And you do know its terms. So you got to find the y-intercept. There's different ways to do that. One way to do it is you could use the slope-intercept form. That's one way. Or you can use point-slope form. So it depends on how you were taught. So I can do this multiple ways. If you use this function right here, y equals m times x plus b, we know the slope is negative 2/3, so I'm going to substitute that in. And so I need to find b. Okay, I got to find the y-intercept. Find b. So what you do is you pick a point on the line and you substitute it in, because x comma y represents a point on the line. So you can use the left or the right endpoint. I'm going to use this one right here. And it looks like it's at negative 7 comma 5. So negative 7 comma 5. So we're going to substitute that in. X is negative 7 and y is 5. So here we go. So I'm going to put 5 here, and that's equal to negative 2/3 times negative 7, and then plus b. So this gives me y is equal to 14/3 plus b. Now 14/3, just so you know, give me a second here, I need some more room. That's what's cool about technology right here. Okay, so 14/3, 3 divides into 14 4 times. 4 times 3 is 12 with 2 remaining, so that's 4 2/3. So 5 is 4 2/3 plus something. So what would you add to 4 2/3 to get to 5? And the obvious answer is 1/3, okay? So b is 1/3. So now I know the linear function. This right here, that is 1/3. So my function looks like negative 2/3 x plus 1/3 on a specific domain. Now the domain starts right here at negative 7 and it ends at negative 4. So again, look horizontally for the domain. So from negative 7 to negative 4. So negative 7 is going to be less than x because it's closed on the left. Less than or equal to x, I mean. Because it's closed on the left, but it's open on the right. So it's strictly less than 4. Excuse me, negative 4. Okay, remember, it's closed on this side, so it's got to be less than or equal to. It's open on this side, so it has to be strictly less than. Closed on the left, open on the right. Now, on this one here, we got a semicircle. Okay, don't even know how to spell, semicircle. Okay, and the radius is 4 now. Okay, this distance right here, that's 4. R is 4. So when you work on the circle, again, you do the same thing as I did before. R squared, x squared plus y squared is equal to r squared. So you get x squared plus y squared is equal to 16. Subtract x squared, just like I did on the previous problem. And you get y squared is equal to 16 minus the x squared. And then you square root. And you get y is equal to plus or minus the square root of 16 minus x squared. And so the upper half is the positive root. The lower half is the negative of the root. So this one's going to be positive the square root of 16 minus x squared from negative 4 to 4. Closed on the left, open on the right. Closed here, open here. It's closed. So that's why I use the less than equal to and then the less than. Okay, and the last part of the function is this linear constant function here. This is a constant function. Y is equal to, let me see, we're down 2 units here. So y is equal to negative 2 from 4 to infinity. Okay, so y is equal to negative 2 from 4 to infinity, or when x is greater than or equal to 4. It's closed right there. So that's why I put greater than or equal to 4. Because it's defined from 4 on, from 4 to infinity. And that, my friends, that is a full-blown tutorial on how to graph piecewise functions and how to write the function given the graph, which is the second part of the activity on 7A3. So that's a lot, you guys. I know this is a long video. It's almost an hour long, but if I went too fast, I would blow people away. So I want to be detailed, and like I said, these contains all the basics here, so make sure you fully understand this before you even attempt the video. The activity. All right, I'm Mr. Ainsworth here at Great Oak High School here in MRWC. Hopefully you learned something, and I'll see you in the class in the next activity. All right, bye-bye.